Welcome to the Surgical Theater. I'm your host, the strategist, and today we are absolutely not treating the Cambridge Mathematics exam like some terrifying, unbeatable obstacle. No, we are treating this past paper as a patient on the operating table. We are going in with precision instruments, steady hands, and a flawless plan. If you've ever opened up a math exam paper, felt your heart start racing, and just stared blankly at a massive wall of complex algebra and geometry, look, you are definitely not alone. It is super intimidating. But today, we dissect these questions with total surgical accuracy. Right off the bat, I want to introduce you to two types of students I see every single year. Picture this split screen in your head. On the left side, we have Alex. Now, Alex is brilliant at memorization. He completely overloads his exam paper with raw mathematical facts and formulas scattered absolutely everywhere. But he has zero structural analysis. He leaves so many marks on the table because he doesn't actually answer the specific question the examiner is asking. Now, look at the right side. This is Sam. Sam rushes. Sam has this imaginary timer ticking loudly in her head, so she misses the crucial command word requirements, she skips essential steps, and she constantly loses what examiners call method marks. Throughout this explainer, we're going to look at their flawed answers marked up in harsh red pen, and we're going to transform them into perfect green checkmark answers. We are going to decode the anatomy of this Cambridge past paper. And listen, whether you're tackling syllabus code 0580, 0606, 4024, 4037, or even 4040, the DNA of these exams is exactly the same. Okay, let's dive right in and turn that exam panic into absolute power.
So, here is our surgical plan for today. We're going to start by decoding the exam's hidden structure. Then, we unlock number theory. After that, we'll visualize spatial logic with sets, translate fractions and decimals, and finally, conquer everyday applied arithmetic. Let's get to work.
Section 1. Decoding the math exam. Looking past the numbers. The absolute most crucial thing you need to understand is that Cambridge exams are not random, chaotic collections of math problems designed just to torture you. Seriously, they're not. They are highly structured, meticulously engineered tests of specific syllabus competencies. The examiners are speaking to you in a very specific language, and if you don't speak it back, you're operating in the dark. Top students don't just randomly do math, they decode. They look at command words, they use proven frameworks. In fact, to secure top marks, you need to apply the Peel framework. Yes, Peel isn't just for English essays, it is a game changer for mathematics. Here is how you structure your math answers. Point. Identify the core mathematical concept and the command word. Evidence. Extract and substitute the exact numbers and data given in the question. Explanation. Show your step-by-step working out clearly, this is your logical proof. And finally, link. State your final answer clearly, linking it back to the question with the correct units and significant figures. Keep Peel in mind as we analyze our first real question.
Now, what's really fascinating about this specific data source is the raw layout we are looking at. At first glance, it's just a wall of numbers, but repeating patterns hide right there within it. I want you to direct your attention to the right margin of the page. Do you see those tiny numbers in the brackets? 1 mark, 2 marks, 3 marks. These are your patient's vital signs. They dictate exactly how much working out is required. A 1-mark question means the answer should be pretty immediate. Maybe a single, straightforward calculation. If you find yourself doing half a page of algebra for a 1-mark question, stop. You've misdiagnosed the problem and you are completely wasting your time. A 3-mark question, however, absolutely demands the full PEL structural approach we just talked about. You need the concept, the substitution, the working, and the final answer. Notice the syllabus code referenced on this paper is 4024. But remember, the strategies we're using today are identical for the 058 IGCSE or the 0606 Additional Math. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's commit to this strategic mindset. We analyze, we don't just calculate.
Let's move into our first major operational zone. Unlocking number theory. This is the bedrock foundation upon which the entire house of mathematics is built. Let's see what examiners are really digging for here.
The core competencies being tested in this first cluster of questions are prime factorization, calculating the LCM, finding the HCF, and correctly identifying square and cube numbers. Remember Alex? When Alex sees a command for prime factorization, he just writes down random factors. For the number 36, he might quickly jot down 4 times 9. He puts his pen down, thinks he's done, and moves on. But he completely missed the command word prime. 4 and 9 are not prime numbers. You have to break them down to their absolute atomic level. 4 is 2 squared, 9 is 3 squared,
So the real answer is 2 squared times 3 squared. That is the surgical precision examiners want to see. Let's see how this escalates. This brilliantly illustrates how the exam scales up the difficulty. Question 1A starts off super simply. Express 36 as the product of its prime factors. Just like we discussed, you break it down to 2 squared times 3 squared. Boom, 1 mark. Quick, clean incision. But then, look at question 2B. The exam suddenly ramps up the pressure by throwing algebraic prime factors at you. It says P equals 2 to the power of n plus 2 times 3 to the power of n times 5, and Q equals 2 to the power of n times 3 to the power of n plus 1 times 5 squared. Sam looks at this, totally panics, rushes the process, and just guesses. But if we apply our strategy, it's actually incredibly simple. To find the lowest common multiple, you just take the highest power of each prime factor present. Between 2 to the power of n plus 2 and 2 to the power of n, the highest is obviously n plus 2. Between 3 to the power of n and n plus 1, it's n plus 1. And between 5 and 5 squared, it's 5 squared. The question tells us the LCM is 2 to the power of n times 3 to the power of n times r. You literally just divide your calculated LCM by this given formula to isolate r. It's just a logical puzzle. When you map it out step by step, those red marks instantly transform into green check marks. Now let's slide over to question 5. This is purely a test of your mathematical vocabulary and your ability to spot traps. The list gives us the square root of 7, 17, 25, 27, and the square root of 36. The command here is to write down a prime number, a cube number, and a square number from that exact list. Here is exactly where the examiner sets a massive trap. Look at the square root of 36. Alex immediately jumps on it and thinks, oh, 36 is a square number, so I'll write that down for part C. Absolutely not. The actual numerical value of the square root of 36 is just 6. Is 6 a square number? No, it's not. It is a brilliant distractor. Let's do this correctly and precisely. A prime number from the list, that's 17. It's only divisible by 1 and itself. A cube number, 27, because 3 times 3 times 3 equals 27. A square number, 25, because 5 squared is 25. That's 3 marks, surgically extracted in under 60 seconds. Stop scrolling. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are now moving from pure abstract numbers into spatial logic. Welcome to Visualizing with Sets. Focus your attention right here on questions 3 and 4. Set theory is ultimately a test of your ability to translate word problems and abstract notation into visual regions on a diagram. We are going into our interactive workshop, Data Scan. Imagine a 60-second timer ticking right now. Can you extract the core trend? Look at question 3. In a group of 35 people, 22 wear spectacles, 10 wear a hat, and 6 wear both. If you try to solve this purely in your head, you will almost certainly double count the people wearing both. You absolutely need a Venn diagram. Let's visualize the transformation. Imagine Sam actually drawing 2 overlapping circles. In the exact center, the intersection, she places the 6 people who wear both. Now, for the spectacle circle, there are 22 total, but 6 are already sitting right there in the middle. So 22 minus 6 is 16. Just 16 people wear only spectacles. For the hat circle, 10 total minus the 6 in the middle leaves 4 people wearing only hats. Now add them all up. 16 plus 6 plus 4 equals 26. But wait, the question stated the group has 35 people. So 35 total minus the 26 we accounted for leaves 9 people wearing neither. They sit outside the circles. By physically drawing it, the logic becomes completely undeniable. Now, I really want to highlight this exact phrasing from question 3. By drawing a Venn diagram or otherwise. Cambridge exams often give you flexibility in your problem-solving approach. But let me tell you a massive secret straight from the examiner's report. That word otherwise is a trap. It is a trap for students who are too stubborn to draw. Students who try to write out complex algebraic equations for set problems usually get totally tangled in their own logic and run out of time. The visual method is not just a polite suggestion. It is the most efficient, surgically precise tool for the job. Do not fall for the otherwise trap. Always draw the diagram. I really want you to look at this giant number 3. 3 marks. In question 4AI, you were awarded a massive 3 marks just for successfully completing the Venn diagram. Think about how we secure those marks using our system. You earn these 3 marks by properly identifying the universal set, which are the integers from 1 to 16, then by accurately listing out set A, the even numbers. Then set B, the square numbers. And set C, the factors of 100. And finally, by meticulously placing those individual integers into the correct overlapping regions on the visual plot. 3 marks might not sound like a huge deal. But in the Cambridge grading matrix, 3 marks is incredibly often the exact difference between a B and an A, or an A and an A star. Every single mark is a heartbeat. You must fight for every single one of them.
So, once you have successfully mapped this visual data, you really have to ask yourself, how does the exam test your mathematical translation skills next? Because mathematics is ultimately a language, and true fluency means being able to translate between totally different dialects seamlessly. Let's find out how the syllabus tests this exactly.
We're moving into fractions, decimals, and percentages. I like to call these the translators, because numbers can wear many, many different disguises. Look closely at the second page of our exercise. Questions 6, 7, 8, and 11. This entire cluster is a dedicated, laser-focused test of your fluency in moving between fractions, decimals, and percentages. Let's do our second interactive challenge, find the flaw. Scan this complex data. What is the core trend the examiner is looking for? The trend is that they want to see if you can manipulate a value without changing its underlying worth. You must be able to instantly recognize that 0.5, 50%, and 1/2 are exactly the same entity, just wearing different masks. If you slip up on the format, you bleed marks.
Let's break down the specific translation tasks. Question 6 is an absolute classic. Write the recurring decimal 0.36 with dots over the 3 and the 6 as a fraction in its simplest form. Here is our flawed sample. Alex writes 0.363636 is roughly 36 over 100, which simplifies to 9 over 25. Bam, 0 marks. Why? Because it's a recurring decimal, not a terminating one. That sentence literally threw away 3 marks. The surgical method requires algebra. Imagine a 30-second timer to write one perfect Peel paragraph. Point. Convert using algebra. Evidence. Let x equal 0.3636 recurring. Explanation. Multiply by 100 to shift the decimal past the repeating 2-digit block. So 100x equals 36.3636 recurring. Now subtract the original x. 100x minus x is 99x. 36.3636 minus 0.3636 leaves exactly 36. So, 99x equals 36. Therefore, x equals 36 over 99. Link. Divide the top and bottom by 9, and you get 4 over 11. 3 marks secured. Flawless algebraic proof.
Now for the ordering challenge. Question 8 gives you a completely chaotic list. 3 over 4, 0.83, 17 over 20, 82%, and 0.8. The goal is to order them from smallest to largest. The strategy here? You have to mentally convert all these mixed formats into a single common language. Decimals are usually the easiest to work with. Let's translate. 3 over 4 is 0.75. 0.83 is already a decimal, great. 17 over 20, multiply the top and bottom by 5 to get the denominator to 100. That's 85 over 100, so 0.85. 82% is 0.82. 0.8 is just 0.80. Now we list them logically. 0.75, 0.80, 0.82, 0.83, 0.85. But remember the critical final link in your Peel framework. You absolutely must write your final answer using the original formats given in the question. So your final line must read 3 over 4, 0.8, 82%, 0.83, 17 over 20. If you just write down your converted decimals, you lose the final mark. Precision matters.
Let's move to our final section, Everyday Applied Arithmetic. This is where theoretical mathematics hits real-world scenarios and incredibly strict operational rules. We are moving from the abstract space of sets and recurring decimals straight into concrete, tangible reality. Direct your attention to the final block of questions on this page, 9, 10, and 12. Notice the distinct shift in tone here. We are dealing with real city temperatures in Celsius, pure BODMS operations dealing with negatives, and strict decimal division. Question 10 is a test of pure operational mechanics. -7 plus 3 times 4. If Sam rushes this, she does -7 plus 3, which is -4, and then multiplies by 4 to get -16. Totally wrong. The universal rules of operations dictate multiplication happens first. 3 times 4 is 12. Then -7 plus 12 is +5.
It's a one-mark question, meaning it requires one precise, disciplined mental maneuver.
I really want to contrast the two different mindsets required here. Look at question 9. It requires contextual, applied logic. On 1 February, the minimum temperature was T degrees Celsius. The text says it was 13 degrees lower than the minimum on 1 March, which the table shows is -5 degrees. So we have to calculate a 13-degree drop from -5. -5 minus 13 equals -18 degrees Celsius. You literally have to visualize the thermometer dropping. Contrast that mindset directly with question 12b, 4.2 divided by 0.02. This requires zero contextual logic and 100% pure mechanical calculation. How do we bypass messy decimals without reaching for a calculator? We multiply both sides by 100 to shift the decimal points completely out of the way. 4.2 becomes 420, 0.02 becomes 2. Now the question is beautifully simple. 420 divided by 2. The answer is 210. By identifying the command word and the core skill, we save time and we eliminate the chance of simple arithmetic errors. This is the exact anatomy of a perfect score.
And that brings us to the ultimate truth of the Cambridge syllabus. Here is the final complete answering system. 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, PEL framework application. Rule 3, the time management matrix based on mark allocations. Once you recognize these recurring themes, the foundation of number theory, the spatial logic of sets, the fluency of translations, and the strict rules of arithmetic, that terrifying wall of numbers becomes a totally readable map. You're no longer Alex overloading the page with irrelevant facts, and you are no longer Sam rushing the clock and dropping easy method marks. You are a strategist. Listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.